Hello everyone, how you all doing? Welcome once again. We've been doing application of derivatives and only one topic is left, that is local maxima and local minima. So it's a bit complicated thing, but it's also very easy, so don't worry about that. And we'll directly do the working method of local maxima and local minima so that it will be easy for you to understand the concept. All right, there are two tests that we are going to do. First is first derivative test. I'll be telling you what steps are involved, and then there is second derivative test. It's totally up to you that what test you are going to apply to find the results. All right, so in first derivative test, our first thing is that we have to find f dash x, means differentiate the function with respect to x once, then put f dash x is equals to 0. Now when you will put f dash x is equals to 0, you will get some values. Let those values are a, b, c. Of course x, the values of x will be there like a, b, c. Alright, now you have to study the sign of f dash x for the values of a, b and c. For example, let x is equals to slightly less than a. For example, if x is 1, then slightly less than value 1 will be 0.9. Alright, then consider the value 0.9 and substitute in the f dash x. If your answer is coming out to be negative, then note down that, and then let a value x that is slightly greater than a. For example, if x is 1, then if a is 1, then x can be 1.1, slightly greater than. And if the sign of f dash x is coming out to be positive, now you can see the sign has changed from negative to positive. And if at any point the sign is changing from negative to positive, then f has local minima. F has local minimum value at a. If it's the reciprocal, if it's changing from positive to negative, then ultimately it becomes local maximum at a. Right, and if it's negative and coming out to be negative again, or it's positive and it's coming out to be positive again, then it becomes a point of inflection. It means neither maxima nor minima. Point of inflection. Now the thing that you have done with a, you have to do with the other values like b and c. All right, you have to do with the other values as well, so that you will get to know the points of local maxima and local minima. All right, so this was the first derivative test to find the point of local minima and local maxima. And when you are to find the value, you find the value of function at that point. For example, f has local minima at point 3, then substitute 3 in your function, not the differentiation, in your function, and you will get the desired local minimum value. All right, this was all about first derivative test. Now we are going to do second derivative test. It's also very easy. Some students find second derivative test easy, some find first derivative test easy. In this, first step is same. Firstly, find f dash x and then put f dash x is equals to 0. Then again x will equal to a, b or c, and these points are known as stationary points. All right, there will be some stationary points. Now we have to study the sign of f double dash x at any of these points. In the first derivative test, we have studied the sign changes of f dash x, not f double dash x. But here we have to study the sign of f double dash x because it's a second derivative test at a, b or c. Alright, now from the sign of f double dash x, you are going to tell whether the function is minimum or maximum, or local minimum or local maximum. Alright, and then if f double dash x comes out to be greater than 0, then it's having local minimum. If it's greater than 0, alright, it's kind of opposite thing. And if f dash x is coming out to be less than 0, then of course it's a local maximum. All right. Now, if f double dash x is equals to 0, then the second derivative test fails in that case, and then we have to apply first derivative test again. If f double dash x comes out to be equal to 0, then the second derivative test fails. So these are the points. This is the working method of first derivative test and second derivative test to find local minima and local maxima. So let's apply these tests to some examples to make things more clear. So let's apply this to our very first example, that is example 29th. We have to find the local maximum and local minimum values of fx is equals to x cube minus 3x plus 3. You have to find the local minimum and maximum values. We'll apply the first derivative test. So what was the first step? It was we have to find f dash x. Now f dash x will be equal to 3x square minus 3. Of course, x cube, differentiation of x cube with respect to x is 3x square, and minus of 3x, it will give us minus 3. Clear? Now what will we do? We will put f dash x is equals to 0. So it means 3x square minus 3 is equals to 0, or x square minus 1 equal to 0. This implies x square equal to 1, or x is equals to plus minus 1. So there are two values, the values which we were talking in the previous part in the first derivative test, that is ABC. So x has two values, 1 and minus 1. All right. Firstly, take x is equals to 1. It's a kind of a for us. All right. That is 1. Now take a value slightly less than 1, say 0.9. At 0.9, study the sign change of f dash x. Alright, what is f dash x? That is x square minus 1, or we can simply write it as x minus 1 and x plus 1. When you will put x as 0.9, now 0.9 is less than 1, so it will give us a negative sign, and it's a positive sign, so it's coming out to be negative. Clear? Now take a value slightly more than 1, say 1.1, only slightly. Alright, then again our f dash x is this. So it is greater than 1 now, so it will give us a positive sign, and this will also give us a positive sign. So the value is changing from negative to positive, and when it changes from negative to positive, it's a point of local minima. Clear? As we have discussed in the first derivative test. Now 1 is a point of local minima, and what will be the local minimum value? Substitute 1 in the function. 1 minus 3 minus 2, 3 minus 2, 1, and local minimum value is 1. Alright, because 1 minus 3 minus 2, 3 minus 2, 1. So we have found the local minima as well as the local minimum value. So now let's take the point minus 1. Now take x is equals to minus 1. Clear? Now take a value slightly less than minus 1. Now slightly less than minus 1, that can be minus 0.9 or kind of that value. That can be minus 1.9 as well, that is less than. All right, any less value. Now you will see that it's less than minus 1. So if it's less than minus 1, then here you are getting the positive sign. Of course, yes, you are getting the positive sign here. And next, if you want to take any value slightly less than minus 1, then you can take minus of 0.9, not in the case of first but in the case of second, and then the sign will be changing to negative, because if you will substitute any value that is slightly greater than minus 1, then you will have a negative sign over here. So that is why the value is changing from positive to negative. So it's a point of local maxima. Clear? Now you have to find the local maximum value as well. So substitute minus 1 in the function. Minus 1 plus 3, 6 minus 1, that is 5. So f of minus 1 is equals to 5. So our local maximum value is 5 and local minimum value is 1. So we have found the local maxima, local minima as well, and the local minimum and maximum values as well. All right. So this is how to apply first derivative test. If you find any doubt regarding any step, you can ask me in the comment section, or you can ask me personally by direct messaging me on my Insta. The link is given in the description. So don't worry if you have difficulty in any step, or not in this chapter, in any chapter of any mathematics. All right. So you can ask me directly. So let's move to the next example to make the things more clear. This is our next example. The function is 2x cube minus 6x square plus 6x plus 5. So let's apply the first derivative test and find the points of local maxima and local minima. Alright, firstly we have to find the derivative. We will get 6x square minus 12x plus 6. Right? Then what will we do? We have to put f dash x is equals to 0. So when you will put 6x square minus 12x plus 6 equal to 0, you can take 6 as common factor. X square minus 2x plus 1 is equals to 0, or x square minus 2x plus 1 is equals to 0. This is becoming a square plus b square minus 2ab. So you will get x minus 1 whole square is equals to 0, which implies x is equals to 1. Now here the only critical point is x is equals to 1. So we have to investigate that is this point a point of local minimum, local maximum, or the point of inflection. All right. So this is x is equals to 1. Say x is slightly greater than 1, that is 1.1. Right. At 1.1, check the sign of f dash x. Now 1.1 square, of course it will be some positive quantity, and 6 multiply that will be positive. This will be negative. Minus 12 when will be multiplied by 1.1, it will be negative, and 6 multiply will be greater. Then plus 6 it will be greater, and minus 12. Of course it will be giving us positive sign. Alright, so if you want, let us check. When you will take the square of 1.1, you will get 1.21, minus when you will multiply 12 by 1.1, you will get 13.2 plus 6. All right, and 6 multiply by 1.21, you will get 7.26 plus of 6 minus 13.2. After solving this, you will get 0.06, which is greater than 0. It means the sign is positive. Clear? Now say x is less than 1, slightly less than 1, that is 0.9. So check the values. Now 0.9 multiplied by 0.9 is equals to 0.81, and that when will be multiplied by 6, we will get 4.86, minus 12 multiply 0.9, you will get 10.8, and plus of 6. Now 6 plus 4.86, it means 10.86 minus 10.8, and when you will subtract 10.86 minus 10.8, you will get 0.06, which is again positive. So you can see that f dash x has not changed its sign at both of the values slightly less than and greater than x is equals to 1. It means x is equals to 1 is a point of inflection. Very simple. All right, so don't be confident every time that the sign will be positive to negative or negative to positive, and it has to be a point of local maxima or minima. Sometimes it can be a point of inflection as well. All right, let's move further. This is our 32nd example. In the 31st example, the function given is very easy, so you can do that by yourself. In one step, you have to take value less than 0 and then greater than 0, and you can solve 31st example very easily. Still, if you find any doubt in 31st example, you can DM me on my Insta. The link is given in description, as you know, and you can also post your doubts in comment section. So don't worry, and you can feel free to ask me about anything. All right, so the 32nd example is this. The function is this, and we have to find local maxima as well as local minima. So firstly, we will again find f dash x. It means 12x cube plus 12x square minus 24x. This is our f dash x. If you will simplify it, you can take 12x as a common factor, and you will be left with x minus 1 and x plus 2 only, because it's x square plus 2x minus x minus 2, and when x will be multiplied, the things will become x cube plus x square minus 2x. All right, so these are the factors. Now we will put f dash x is equals to 0. What will you get? 12x, x minus 1 and x plus 2. Now here there will be three values. Firstly, if 12x is equals to 0, then x is equals to 0. If x minus 1 is equals to 0, then x is equals to 1. If x plus 2 is equals to 0, then x is equals to minus 2. So we have three critical points, that is 0, 1 and 2, and we will check the sign of f dash x. You can check the sign of f dash x on these values as well, and you can apply second derivative test as well. So to understand second derivative test clearly, let's apply second derivative test in this example. All right, now for second order derivative, you have to find f double dash x. So what will you get? When you will differentiate, you will get 36x square plus 24x minus 24, right? This is double differentiation. Now you can again take 12 as a common factor, 3x square plus 2x minus 1. All right, and 12 3s are 36, 12 2s are 24, and minus of 24. Here it will be 2 only. All right, so this is f double dash x. Now you have x is equals to 0. You have to check the value of these critical points in f double dash x. When you will put x is equals to 0, you will get minus of 24, that is less than 0. Clear? When you will put 1, what will you get? 36 plus 24 minus 24, it means 36, which is greater than 0. And f double dash minus 2, because that is our third critical point. So when you will put minus 2, this will become positive, this will become negative, and this will become negative, and the answer is coming out to be 84 according to the book. All right, so you will get 84. Now on this point, it is less than 0, so it's less than 0, that is why it's a point of local maxima. Now these 2 points are of local minima. Now we also have to find the local maximum and local minimum values, right? So substitute x is equals to 0 in your function. You will get 0 0 0 0 0 and 12. So our local maximum value is 12. All right, I am skipping some of these steps to make things more clear, because you can write that substitute 0 in the function and all of those things you can write. So f double dash 1, 3 plus 4, 7 minus 12 minus 5, 12 minus 5, that is 7. So first local maximum value is 7, and then minus 2. 2 2s are 4, 2s are 8, 2s are 16, and positive 16. So 16 multiply 3, that is 48, plus 2 2s are 4, 2s are 8, minus of 32, minus 2 2s are 4, 48, plus of 12. When you will solve this, you will get minus of 20. This is our second value of local minima. Alright, so this is how you can find the value of local maxima and local minima using second derivative test. Some students find this easy, some find first derivative test easy. Now talking about the next examples, that is example 33. There is also a function given, and it can be solved by following the same steps that we have discussed so far in this video. I am pretty much sure that you can do example 31st and the 33rd by your own from NCERT mathematics book, and I wish you all the very best for trying those examples and all of the sums. So this is it for today, and we will be doing our application of maxima and minima in our next video for sure. Till then, if you have any suggestion or any query, feel free to ask me or suggest me anything regarding my videos, and I am getting great response, so thank you all for this, and I'll be more than happy if I will get some queries from your side as well. All right, until then, keep practicing. Don't forget to subscribe my channel before leaving, and also share it with your friends and other family members you think are in the need of these kind of videos. All right, so we will meet in the next video. Till then, bye bye, keep practicing, happy practicing.